Historically, it's kind of interesting to think about anatomy and physiology because how are you going to study anatomy? I mean, anatomy is literally the study of the names of all the parts of the body, the thousands of parts of the body. How are you going to study that? Where are you going to cut people up? And that's what anatomy means. Literally, if you translate the word anatomy, quote, to cut up, unquote. So how are you going to study anatomy without cutting people up? Well, who wants to be cut up? Well, nobody. Who wants to donate their dead loved ones to be cut up? Well, nobody. So how do we do it? It was basically against the law. So we had people that dug up the dead, robbed graves, and dropped the dead people off behind a building in the middle of the night. And so now the people trying to study anatomy had people to cut up. That's how it all started. It was kind of crazy. So anatomy are the names of all the parts of the body. Kind of like going out in the parking lot to one of our cars. We say those are the tires. There's the exhaust pipe. Let's raise the hood. There's the air filter. Those are spark plug wires. Well, what do they do? Oh, no, I'm not going to tell you what they do. No, this is just anatomy. The names of the parts. If I tell you what they do, that would be physiology. Okay, so that's the difference between anatomy and physiology. Anatomy is the names of the parts. Physiology is what do they do? How do they work? So while anatomy literally means to cut up, working definitions of anatomy and physiology would be structure and function. Structure and function. So if we go out in the parking lot and we raise the hood of the car, we say there's the air filter, there's the spark plug wire, that's anatomy. Okay, now here's what they do. That's physiology or functionality. So again, historically it's kind of interesting because it was basically illegal. People had to steal dead people to have bodies to cut up. And as far as the functionality, it was, oh, it's God. Don't question it. You'll go to hell. We'll kill you. That was the attitude. And that attitude prevailed in many instances for decades. In fact, it was the 1950s before people started studying sex. And imagine people in the 50s trying to study sex when you can't even show a man and woman in the same bed on TV. Anybody remember the old reruns? Mom and Dad slept in separate twin beds with a table between the beds. They always had to have one foot on the floor, fully clothed in long sleeve pajamas. And so in that era, some researchers, their names were Masters and Johnson, not Johnston. They wanted to bring people into their lab and study sexual intercourse. They put up signs seeking volunteers. They didn't get any. We'll talk more about this next semester in the context of reproductive physiology. But so it's fascinating to look back at it historically. But again, a working translation for anatomy and physiology would be structure and function. Now, structure and function go together at every level. So we could start at the gross level, which generally speaking means you can see it with the naked eye. We could talk about the forelimbs of different animals. Not F-O-U-R. So you have forelimbs, we call them arms. You can write, you can throw a ball, you can paint, you can do a lot of things with your forelimbs. Your dog has forelimbs. It probably doesn't paint very well or throw a ball very well, but it walks quite well on its forelimbs. You're capable of walking on your forelimbs, but it's rather cumbersome. They're not designed for that. So your forelimbs have a structure that allows particular functions. Your dog's forelimbs have a different structure that allows different functions. What about a bird? Does a bird have forelimbs? And what do we call them? Wings. Structure and function. Okay, so they go together, absolutely. Anatomy is a subject, physiology is another subject, but they go together. The only time anatomy and physiology are mixed in the same book or the same class is at this introductory level. After that, they're always separate subjects: advanced anatomy, medical physiology, reproductive physiology, cardiovascular physiology. But they're linked at the introductory level, because what fun would it be to go out in the parking lot and name all the parts under the hood and not talk about what they do? Be kind of boring, kind of dry. Oh, well, I can name everything, but I have no spark plug. I don't know. Maybe it's if your cigarette lighter doesn't work, you know. So we link them at the introductory level. Structure and function, every level, the gross level. Again, I've mentioned the bird, the dog. How about a fish? Does a fish have 4 limbs? It does. We call them pectoral fins. Even a snake has remnant forelimbs. How about the cellular level? We could talk about a muscle cell. Okay, so what do muscles do?
They contract so
They contract to move bones. And I talk a little bit about this in that document that I loaded yesterday, because I know it's very abstract to start memorizing that muscle chart: origin, insertion, action. What does origin mean? What does insertion mean? So I tell you in that document right up front. But muscles basically span a joint so that muscles can contract, and when they contract, they get shorter, and that moves bones. So muscle cells contract, which makes the muscle contract. So muscle cells are specialized to contract. That's what they do. How about nerve cells? They don't contract. They conduct signals. They conduct signals almost like electricity. Very similar to electricity, in fact. So the structure of a muscle cell is such that it can shorten, contract, and all the cells working together constitute the muscle-moving bones. But nerve cells, on the other hand, conduct these electrical-like signals. You have cells in your stomach that make enzymes that break down food that you've eaten. Structure and function at every level. How about the molecular level? Let's think about the structure of a cell membrane. So you know that the cell membrane is a bilayer of phospholipids. If we take a little piece of that membrane and we blow it up, we can see the phospholipid bilayer, where each of these is a phospholipid with the phosphate group constituting the hydrophobic or polar head, and the 2 squiggly lines constitute the hydrophobic tails, the hydrocarbon chains. And because the cell membrane has this structure, it serves as a regulatory structure, controlling what can get in the cell, what can go out of the cell, everything that you've studied about the cell membrane in biology. What if the cell membrane was a bilayer of glucose molecules? Wouldn't work so well. Glucose is a hydrophilic molecule. It's this hydrophobic fatty core of the membrane that makes it a regulatory structure. How about the atomic level? So what do we know about the periodic table? Well, we remember the red stairs there, and everything to the left of the red stairs is a metal, and everything over here is a non-metal. And we know that the metals always lose electrons to meet the octet rule. And so, for example, lithium has 3 electrons. It's going to lose 1, leaving it with 2. That satisfies the octet rule, 2, 8, 8. So everything over here loses electrons to satisfy the octet rule. When they lose electrons, they become positive. The things over here gain electrons to meet the octet rule. When they gain electrons, they become negative. So now something positive and something negative are attracted to each other. We call that an ionic bond. Well, that won't happen between oxygen and nitrogen, will it? Because they're both nonmetals. Now they can stick to each other using a word because I don't want to say bond at that moment. But what type of relationship, interaction do we have when oxygen and nitrogen stick to each other? Covalent bond, and what's going on there? Sharing electrons. Structure and function. So we have structure and function at every level. Your dog cannot throw a frisbee. You don't walk very well on your forelimbs. We have structure and function at every level. So we can study anatomy and physiology at every level. And that's what histology is all about, the cellular or the tissue level of structure and function. All right, the next topic here, letter B, branches of anatomy and physiology. It's kind of like healthcare. Nobody can be an expert in all of it. I bet you've never been to an orthopedic surgeon who was also a gynecologist. I mean, a person could do that, but it'd just be you'd be 60 years old before you were finished with school. So everybody specializes. Your general practitioner, your primary care physician, he or she knows a lot. And they know a little bit about everything. But if you go in there complaining of chest pain, God, I can't even get my breath right now. And last night all I was doing was helping my son change a flat on his bicycle, and I had to stop and catch him. Where's the doctor going to send you? Probably the ER, but what type of doctor is the primary care physician going to send you to? A cardiologist, yeah. If you've got a broken bone, you go to an orthopedic surgeon. If you've got a problem with your hormones, you see an endocrinologist. So everybody specializes. Well, it's the same way in school. I mean, you don't have an electrical engineer who's also a mechanical engineer. You could, but you just don't. Everybody specializes. So in anatomy and physiology, we have a lot of different branches. The easiest way to get a handle on the branches of anatomy and physiology is just to look at the table of contents in yours isn't open. That's the only reason I didn't grab it. But look at the table of contents in here. What do you have after the introductory material? So in other words, you've got a chapter on cells, a chapter on chemistry, histology. Once you get past all of that, you've got the integumentary system, the skeletal system. Well, the skeletal system, that's like the orthopedic surgeon. The muscular system. The nervous system, that would be a neurologist. The endocrine system, cardiovascular system, respiratory system. So a pulmonary doctor who treats someone with emphysema is probably not going to do anything with a patient that has ulcers. That person would see a gastroenterologist. So specialization, again, table of contents, very, very easy way. You gotta take this one. Very, very easy way to get a handle on those branches. I've given you a list of branches. It's not definitive by any means. A lot of them are obvious, like cardiovascular, but the ones that aren't obvious, I will mention. So number 2, comparative. What do you want to compare? And you could compare the anatomy, or you could compare the physiology. I know, let's compare this. How come, we all just watched the Olympics. How come the men and women didn't compete together?
Because they're different.
That's sexist. Why do we have female gymnastics and male gymnastics? Why do we have a woman's marathon and a men's marathon? How come? Because we have different anatomy, giving us different functionality. Right or wrong, like it or not, it's the way we are. Different sized lungs, different sized hearts, different body compositions. We're different. So if you studied those differences, that would be comparative. Now just studying the differences, you could say that's comparative anatomy, but then when you get into what are the results, the consequences of these differences, that would be comparative physiology. They're going to go hand in hand. What else might you want to compare? How about let's compare preteens to teens, their bone structure. Why isn't it safe or a good idea for a 10-year-old to train to run a marathon? If you don't know, a marathon is 26.2 miles. Don't ever ask somebody how long the marathon was. Why isn't it safe for a 10-year-old to train to run that distance? But it's fine, you know, after you're 16, 17, 18 years old, depending on who you ask. You could compare the structure of the forelimbs of a dog to a cat. Now, they're similar, at least more similar than us to the dog. But the structural differences in the dog and the cat are why when you, don't go home and do this, but you throw the cat up in the air, it always lands on its feet. You throw the chihuahua up in the air, you'll kill it. Don't go home and do that. Number 3, cytology or cellular physiology. Well, that's at the cellular level, you know, looking at the structure and function at the cellular level. So, drawing from an example from this morning, the nerve cell versus the muscle cell. Number 4, developmental. That's pretty obvious, but you're studying development. What's the development could be whatever range you wanted. So we've got the embryo. Well, I mean, we could even start before that. So sperm plus egg, embryo, death. We've got a fetus in here. We've got a, what do you call the little kids that can't walk yet?
Babies?
No, they're toddlers, they like toddle, don't they?
Oh, yes.
I don't know, crawlers, toddlers, whatever, you know, preteens, teens, middle age. So what are the changes that occur? Developmental anatomy, developmental physiology. What changes occur? And you might be interested in the changes that occur between an embryo and a fetus. You might be interested in the changes that occur at puberty. You might be interested in the changes that occur after 50 or 60 years old. How come mammal's shorter? All right, endocrinology, pretty obvious. Number 6, the word gross. When you say gross anatomy, we've really got 2 things we can do with that. We can see it. So you'll hear me say over the course of the 2 semesters, at the gross level, meaning you can see it with the naked eye. But the other word for, or the other use of the word gross is regional anatomy. So studying the anatomy of different body regions. Now in the context of regional anatomy, that would be versus systems anatomy. Systems anatomy is what we do. All introductory classes use a systems approach. Again, table of contents of your book. Integumentary system, skeletal system, muscular system. When you study system by system by system, you visit any part of the body that has parts of that system. Question?
Is there gross physiology as well?
No. No. So if the system is the skeletal system or the muscular system, you're going to tour pretty much every part of the body. But if the system's the respiratory system, you probably don't have to visit the feet. Okay? When you say gross anatomy, which is any advanced class, another word for that would be regional anatomy. So you have anatomy of the head and neck, anatomy of the arm, anatomy of the leg. Is my pre-physical therapy person in here? Must be the afternoon class. But so examples in here, the physical therapy students, after they take a class like this, they take an undergraduate class in gross anatomy. Then they take a graduate class in gross anatomy. Then they take a graduate class in head and neck anatomy. The nurse anesthesiologists then take a graduate class in neuroanatomy. So the region can be broad, like head and neck's pretty broad compared to neuro. Okay. Anyway, so systems versus regions. And then the other word, when we say at the gross level, we're talking, we can see it with the naked eye. Histology, the study of tissue. Histology comes up because of what is known as levels of organization. And most of you can just flip to that page in your notes. I'm trying to be cognizant of a couple of people that just added to class, as well as a couple of people that might not have been able to print the lecture notes. So this, again, most of you can just turn to this page, but you'll see the title here, Levels of Organization, and this is histology, the study of tissue. And we have to study tissue to make sense out of everything down here. Our goal, of course, is to understand the organism. You, me. If we're going to understand the organism, we have to understand all the systems. To understand any system, we have to understand the organs that are part of that system. So if we're going to understand the digestive system, we have to know something about the stomach, the intestines, the gallbladder, the liver, the pancreas, etc. Well, the organs are made out of tissue, and that's why we have to study the tissues. And as I talked a little bit about on the document that I posted yesterday, when you study histology, you're sort of introduced to many systems in the body. So right now, this is simply in the context of item 7, histology. Number 8, pretty obvious, immunology. Somebody who specializes in the immune system. Neurology, pretty obvious. Renal, that would be like the urologist. Pretty obvious. Number 11 is kind of boring. Surface, probably not any surface physiology. It would be surface anatomy, but it means things you can palpate. Okay, so take your fingers and feel the bump behind your ears. It has a name, mastoid process. Doesn't matter today what its name is. Feel the bridge of your nose. Feel your electron. You probably call it your elbow. So if you can palpate it, that would be surface anatomy. Like I said, kind of boring. Number 12, systemic, talked about that. And I don't know what happens here. I guess we can thank Bill Gates, but after 12, we start over with 1 through 4. I think a former TA might have actually done that because those are my areas. But altitude physiology, how does the body adapt to altitude? In other words, let's say you weren't born. Who wasn't born here? Okay. So what changes did we undergo when we moved here? How long did those changes take? When you got here, how long was it before you could run as comfortably as you ran at sea level? Now you don't run as fast, but you run as comfortably. It's just a little slower. Well, just in a nutshell, you don't even need to write these down, but you made more red blood cells. You made more hemoglobin. Your muscle tissue developed more mitochondria. You guys remember from biology that mitochondria have their own DNA and replicate independently? Your skeletal muscle cells, pick a muscle, one of your quadriceps, they have more mitochondria than people at sea level. So more red blood cells, more hemoglobin, more mitochondria in your muscle cells. There's a protein that stores oxygen in our muscle cells. You have more of that. Because you have more mitochondria, you have more electron transport chains running. See, we're like the Toyota Prius. The people who live at sea level are the Ford F-350s. And if you moved here, you had to convert yourself from the Ford F-350 to the Toyota Prius. Okay, but how can people come from sea level and just last Saturday and Sunday ran the Pikes Peak Ascent and the Pikes Peak Marathon and do well? How's that possible? And any of you that do the incline or love the bar trail and train on the incline and train on the bar trail would agree with me when I say it's very, very humbling to be at 12,000 feet, which is about the level of the A-frame, and be passed by somebody from Missouri. The mountain's in my backyard. I can go there every day. How did this guy or gal from Missouri prepare for this? Okay, so all of that would be this world of altitude physiology. How come Ed Viesturs, if you don't know who he is, it doesn't matter, but can climb Mount Everest without supplemental oxygen faster than other people can climb it with supplemental oxygen? When they made the IMAX movie, Ed climbed without oxygen, and so he left before the rest of the team because they figured he'd be so slow compared to the rest of the team that was climbing with oxygen. When I say left before, they'd spent the night at 26,000 feet. Now, if you don't realize how high that is, realize that our little neighborhood mountain over there is 14,115, and if you think it's 14,110, well, it used to be, but it grew. Anyway, so they slept here, and they're going to Summit. They're making the IMAX movie about Everest. Ed left first because he's climbing without oxygen. They assumed he'd be slow. Well, they never caught him. He kept stopping to rest, waiting on them to catch up. They couldn't catch him. He'd stop and rest until he's freezing to death, because without oxygen, you get really, really cold fast, and he'd have to start moving to raise his body temperature. He had to reclimb part of the mountain so they could make the movie. The part of the movie where you see Ed summiting, it's fake. He's already done it. How come he's that way? Okay, so all of that would be altitude physiology. Of course, there's a lot of exercise physiology that goes into all of that. But we can talk about exercise physiology without bringing altitude into it. You know, what's going on with these people that can run 26.2 miles? The record's under 2 hours and 5 minutes. I don't know what it is. I believe it's 2 hours and 3 minutes and change. How do they do that?
Lots of practice.
Do you guys realize that this is running sub 5-minute miles? How many of us have ever run one sub 5-minute mile? Much less 26 of them in a row. How do people do that? How about the crazy races we have in the Rocky Mountain region? The Leadville 100-mile trail run. And Matt Carpenter, who holds all the Pikes Peak records and most of the trail running records in the world, shattered the Leadville record. Did you know that Matt can do, who does the incline? Do you guys know that Matt can do the incline in 18 minutes? Can you imagine that?
Hell no.
18 minutes! Ungodly. And he's like a little, well, no, he's like me, he's old. But he's a little guy like me, a little guy from Mississippi. It's not like he was born in Leadville and grew up at 10,000 feet. He went to Vail one year to either ski or play or something and fell in love with the mountains. And so he moved to Colorado. Exercise physiology. Medical physiology is pretty obvious. You're relating physiology to medicine, healthcare. Anything you want to talk about, coronary artery disease, strokes, pH imbalances, any pathology. In fact, a lot of you will take, after you take 201 and 202, you'll take, and I don't know the course number or I'd use it, 216, thank you. So I say a lot of you because any of you going into nursing, you'll take pathophysiology. So here we learn how the body works, here we learn how it breaks. You have to learn how it works first. Tell me, and I may have said this Monday, but I think I just said it to the afternoon class. Do you stand a chance of fixing a broken refrigerator if you don't know how the refrigerator works when it's working properly? You're going to fix a broken computer when you don't know how it works when it's working properly? So you learn how it works, and then you learn about how it breaks. Anyway, so that would all be medical physiology. Reproductive physiology, pretty obvious. Reproductive system, again, table of contents of your book. Okay, so. All right, levels of organization is next, and that's on the board from some other context a few minutes ago. We're going to if we're going to be able to fix the broken organism, we have to understand how the organism works. And to understand how it works, we have to understand everything that comes before it. It's no different than anything else you've learned in life. If you go back and you think about it, you all learned addition and subtraction before you learned multiplication and division. You all learned how to manipulate whole numbers before you dealt with decimals and fractions. You mastered all of that before you got into negative numbers. And then those of you that have taken college algebra, much less trig and calculus, you even got into imaginary numbers, which is still sort of abstract in my opinion, but fascinating nevertheless. Reminds me of a show I love. Who likes the Big Bang Theory or the Big Bang Show? Man, I love that. I love Sheldon. I think Sheldon's so cool. Sort of a geek, but anyway, so we have to start at the beginning, and this, of course, is what the prerequisite material was all about, was getting those foundations. And the foundations are so important that we review a lot of it in this room. As you know, you've looked at the syllabus and the lecture notes. We're talking about people. So Roman numeral 3, it's kind of nice to put in perspective where people fall into the scheme of other living creatures. Of course, there's a category above this one. A lot of you know about that because you've taken micro or some high school biology, but we don't have to have it to make sense out of this. But imagine we're going to go out into the world and collect one of everything and put them in boxes, organize them. So, okay, I'll take all the animals, you take all the plants. Well, that's the kingdom. Animalia versus Plantae. Well, there are a lot of different animals out there, so I'll take the chordates, you take something else. And we work our way down. And so right here, for example, things that everyone will be familiar with, we have fish, birds, amphibians, reptiles, and mammals. So I'll put all the mammals in this box, you put all the amphibians in that box, you put all the reptiles in that box. So we keep subdividing. So a guy named Carl, many years ago, created this system. It's actually called taxonomy. He was a student of mine. You knew him. We played checkers with him that day. It was very short summer in Telluride, chilly the entire season, I remember. Do you?
No.
Good, because I made that up.
I figured.
So we work our way down, and we get to finally the genus and species, which constitutes something's scientific name. And if you have these notes in front of you, fix that. So you write the genus and the species in italics. If you don't have a word processor, you underline them. The name of the genus is capitalized, the species is lowercase. And so, as you've known for years, you are a Homo sapien. Well, what does that mean? Well, Homo is your genus, sapien is your species. If you have a dog at home, anyone have a dog at home? Your dog is Canis domesticus. A wolf is Canis lupus. So they're very similar. Anybody have a cat at home? Cats are scary. 2 whole people raise their hand. Felis domesticus is your cat. Anyone trapped a mouse in their garage? Mus muscularis. It was a big mouse. It wasn't a mouse. It was a rat. That would be rat ratus. You get some dirty lettuce and make yourself sick. You ate some Escherichia coli. So everything has this specific name and is organized into these categories. So understand how people fit into all of this. When we start talking about body parts, and this is in front of that, or this is below that, this is, of course, we don't use words like that. We have special words that mean the same thing. But we have to picture the body in a certain position. If we don't have the body in in this certain position, then what I say is above, you might see as below. I mean, let's say we're at the site of an accident, and this is above that, this is below that. So anyway, we have this position called anatomical position, which is pretty much like that. So you're standing with your feet, not like this, but not like that. They're a little bit apart. And the palms of your hands face forward. So this is anatomical position. And no, I don't hang out this way. But it is anatomical position. So even if you're at the site of an accident and somebody's hanging off a mountain with a rope around their neck and one leg over there, whatever, you still describe things as though they are in anatomical position. Now when we describe parts of the body, sometimes we have to make cuts or make sections through the body. And there are two basic ways you can cut something. You can cut it along its length, or you can cut it in half. I wish this was bigger, but if it will work. So if we use this cord, I can cut it along its length. That's called longitudinal. You'll see that word on your notes. Or I can cut it in half. That's called horizontal, transverse, or cross. And again, you'll see that on your notes. In fact, you see all of those words on your notes. That's about all I can do to it. I can cut it along its length, longitudinally. I can cut it in half, cross section. But now let's relate that to a living creature. Well, if you cut me like this, that's longitudinally. But if you cut me like this, that would also be longitudinally. The difference between me and that power cord is I have a front, back, left, and right. The power cord doesn't. Okay, so your garden hose is like the power cord. There's no front, back, left, and right to the garden hose. You can cut it longitudinally or horizontally. When you've got a front, back, left, and right, if you section like this so that you get a left and right, that's called sagittal. You see that word on your notes. Sagittal. Gives you a left and right piece. Now sagittal doesn't have to be right here. It might be. Okay, this is the imaginary line called the midline. And if you cut the creature this way, it's called mid-sagittal, because you get an exact right and left piece, half, whatever. But this is also sagittal, because you get a left and right piece. Is this sagittal through my arm? Why is this not sagittal? Because I'm not in anatomical position. This would be sagittal through my arm. This is not. So sagittal gives you the left and right. If you cut in such a way that you get a front and back, it's called coronal. So this piece going through or that way would be a coronal section. So back to the question I asked you a moment ago with my arm. My arm was like this, and I said, is this sagittal? And the answer is no, because I'm not in anatomical position. If I'm in anatomical position, now that's sagittal. But because my arm was this way, put me in anatomical position, that was actually coronal. Take my finger. If I slice my finger like this, am I going to get a front and back or a right and left piece of my finger? Front and back. Because this is anatomical position. So if I slice my finger that way, that's a coronal section. If I want a sagittal section through my finger, I'd have to slice my finger that way. So you have to picture anatomical position when you play this game. But I pointed out that a horizontal is also called transverse cross. Frontal is also called coronal. In other words, those are The other way that something might be cut is oblique. I don't know that we have a picture showing that. But an oblique section is a diagonal section. So we use oblique sections a lot of times if we've got a tube. If we were looking at the intestines, if we were looking at a longitudinal section, it would look like that. If we were looking at a cross section of the intestines, it would look like that. Well, if we took the tube and we cut it diagonally, we'd get the best of both worlds. And that's the oblique section. So if you take this tube and you make a diagonal cut through it, you get part cross section, part longitudinal section. I don't even care what this, well, I'll tell you what it is, because a lot of you, most of you hopefully are working on your histology books. But so, well, first you tell me, if I tell you these are tubes, are these cross sections or longitudinal sections? Those are cross sections. Those are actually kidney tubules, and these are cross sections through kidney tubules. Areas like this or this are longitudinal sections through a lower magnification and through those same kidney tubules. What type of section do we have here? Cross section. So anyway, we can section not just the body, okay? So it's not just looking at pictures like this. We could section the arm, the finger, the uterus, the trachea, the fallopian tube, the gallbladder, whatever it is that we are studying. Okay, when I mentioned anatomical position, I said we have to picture things in anatomical position. So we say this is on top of, below, in front of, behind. Then I said we don't use any of those words. We have our own special words. And that's what this section deals with. We're on page 5, directional terms. So the first two, superior and inferior. Well, superior is above, inferior is below. So if you take a look at me, is my nose above or below my mouth? My nose is superior to my mouth. My mouth is inferior to my nose. Okay? So that's how we use those words. We rarely use these directional terms with one body part. Okay? We usually have to be comparing A to B. So as we just did, my nose is superior to my mouth. You just say my nose is superior, for what? That doesn't have a lot of meaning. Like this morning, I almost wrecked on Powers because there was this huge thing in the road and I swerved to miss it. What was it? I said it was a deer? Anybody have another idea what I swerved to miss? It was a flea. Why did I call it huge? Because my frame of reference was a virus. So you can't say it is superior. It has no meaning. It is superior to something else. So superior, and you see on the notes there are other words that you can interchange. Now it's kind of interesting, and your lab manual shows you this. I didn't bring those pictures. But if you have dogs or cats or other animals that walk on 4 legs, the way some of these words are interchanged is different than it is for us. I won't ask you questions about that because it's human anatomy and physiology. But I think it is interesting, and it's something I would look at in the lab manual, just for fun. All right, so next words, anterior and posterior. Anterior is toward the front. Posterior is toward the back. So my face is on the anterior aspect of my head. My vertebral column is in the posterior aspect of my body. My belly button is on the anterior aspect of my body. Somebody, probably in the room, it was Monday in the lab, they were asking about the heart versus the vertebral column. The heart is in front of the vertebral column, so it's anterior to the vertebral column. We were working in lab exercise 1. In fact, you could visualize that right here. I don't know if this picture is from the lab manual or the textbook, but so what type of section is this through the body? Cross section. So it's like the person's laying on their back and you cut them in half, and now you're looking inside their body. Is it abdominal or thoracic? Thoracic, because we've got lungs and a heart. If it was abdominal, we'd have stomach and other guts. So here's the vertebral column. That's posterior. You can all palpate that. So the heart is anterior to the vertebral column. It just means in front of. So, every field has its own language, I suppose. Letters E and F, medial and lateral. So again, we have this imaginary line. It's called the midline. So my eyes are anterior to my ears. Ears, eyes are in front of my ears. But aren't my eyes a little closer to my midline? So my eyes are anterior and medial to my ears. Anatomical position. Oh, before we do this.
So lateral is the opposite of medial?
Lateral is the opposite. So here, let's do this. So my nipples are superior to my belly button, but my nipples are also lateral to my belly button. My eyes are lateral to my nose. What word are we talking about? The word medial or the word middle? Medial. Medial. What does medial mean?
Toward the center.
Toward the midline. What does middle mean? In between. Okay. The words are not interchangeable. Toward the midline, in between. I just wanted to clarify that before we do the following. Still applying medial and lateral. So anatomical position, use lay terms. Which finger is the most medial finger on this hand? Use lay terms. The pinky. Now you're not talking about middle finger. The word's medial, okay? That's why I paused and did that. So why is the pinky the most medial finger on my hand? Because it's closest to the midline. So which finger, it's not even a finger, but which finger is the most lateral? My thumb. Okay, so now let's quit calling it a finger. They are digits. Digits. So my thumb is my first digit. My pinky is my fifth digit. So now, what's the most medial thing on my hand? We're not going to say pinky. Fifth digit. And the lateral most is first digit. Right, on your feet, what corresponds to your thumb?
Big toe.
Your hallux.
Hallux or big toe, and pinky corresponds to the little toe. So what's the number for the little toe? Fifth digit, okay. So what's the number for this digit?
3.
3. What's this one?
4. 2.
4. This is 2. 1, 2, 3, 4, 5. Thumb is 1, pinky's 5. Hold on to this, we're going to go further with this. We just need to move our way down the list a little more. So we've been talking about medial and lateral, right? Internal versus deep. So internal or not internal and deep mean the same thing. Internal versus external. Internal is deeper in the body. External or superficial is more outside the body. So we could talk about, for example, your skin is superficial to your muscles. If we look at an organ in cross section, this is not that it matters, but this is a what type of section is this? Cross, along, or longitudinal?
A little bit of both.
Kind of both, so therefore it is oblique. Okay. So if we look at the cross section over here, we can see different layers of the organ. So this is the superficial most layer. This is the deepest layer. If you go home and you take your garden hose, you cut it in half. That's the wall of the garden hose. The opening of the garden hose is called the lumen. The opening of the pipe that feeds your ice maker is also called the lumen. The opening of your trachea or your ureter or your urethra or your fallopian tube is called lumen. This is not a special word. So this is the internal or deep aspect of the wall. This is the external or superficial aspect of the wall. And what we see when we study tubular organs is we see that very often there are multiple layers in the wall. And the different layers are made of different tissues and have different names, and it's not complicated. It's just, it is what it is. It's part of understanding it. All right, I and J. So now we get back to something where we can use the fingers to continue a little bit. So we've established that you have 5 digits, not fingers, but 5 digits on your hand, and your hand isn't really your hand, it's your manus. You guys know everything has a name. Even the plumber's crack has a name. Plumber's crack is your gluteal cleft. Everything has a name. That piece of tissue that's behind your scrotum or vagina, yet in front of your anus, has a name. Every part of your body has a name. And the elders, who I refer to quite often, the elders meet a couple of times a year. They sit around a huge oak table. And they pass body parts around. And they say, what doesn't have a name? These are old, like, 110-year-old, 90. I think you have to be 92 to join, and 110 you're dead and you're done. So, but what doesn't have a name? What only has 3 names? And they just, their job is to torment students taking introductory anatomy or anatomy and physiology classes. They're cool people. Anyway, let's continue. So we've got words proximal and distal. And we're going to continue thinking about the fingers. I don't draw very well, but so this is going to be an anterior view. So I'm In other words, anatomical position. So this is the front. The word for that is anterior. I'm going to draw it like this.
Better than I can draw.
I was going to say, that turned out pretty darn good. I mean, normally when I draw a circle, it looks like that. All right, look at your digits. How many bones do you see in your thumb?
None, you only see skin.
Okay, 50 bonus points on the final for you. I lied. How many bones do you see in your thumb? Two. How many bones do you see in all of your other fingers?
3.
Okay, those bones in your fingers and your toes are called phalanges or phalanges, depending on what side of the Mississippi River you grew up on. Colorado is a melting pot. Nobody was born here, except when I say nobody was born here, then everybody in the room was born here. But if you're on the East Coast, everybody says everything the same way, discounting the differences between Maine and South Carolina, of course. But anyway, Colorado, you hear every possible pronunciation of words because nobody was born here. We're a melting pot. So phalanges are phalanges. So we know that I remember I said, I'm drawing this, so that's the thumb, which is the first, the pinky, which is the fifth. So we need a way, though, to differentiate the 3 bones in the finger, one from the other 2, and as well as the 2 in the thumb. So we're going to use the words proximal and distal. In the word distal, see the word distance. So something's distal, it's a greater distance. In the word proximal, see the word proximity, just to give you some idea of what we're talking about, the proximity of this to that. So to specify one of these bones, say this one, we would call that the second distal phalange. Remember what I said I'm drawing? Is it right or left? Hand or foot?
Menace.
Well, yeah, but we'd actually just call it hand in this case. So second distal phalange, left hand. We wanted to name this one. Name it exactly like this. So what are you going to say first? Fifth? Next word? Proximal? Next word? Well, we talked about medial and lateral, and medial means toward the midline, lateral means away from the midline. What word means in between? Middle. So this bone would be third. Next word?
Median.
Medial means toward the midline.
Median.
Median or middle.
Did I use intermediate?
Or intermediate. Median, middle, intermediate, all of those mean in between. Guys, this stuff isn't difficult, but it's picky. It's picky. Now, just for clarity, the bones we're looking at here are in the A hand, B fingers. Fingers. So if we added, just for perspective,